Hi friends, in this video we are going to discuss what is the logical equivalence. What is the logical equivalence? Logical equivalence means if you take any two statements, when can we say the two statements are equivalence statements? When can we say the two statements are logically equivalence? Right? Let's suppose any compound propositions, P and Q are any two compound propositions. They are said to be equivalence. They are said to be equivalence if P by implies Q is a tautology. P by implies Q is a tautology. What do you mean by tautology? So tautology means is nothing but if the compound statement is always true, if the compound statement is always true, then we say that the compound statement is a tautology. So if P by implies Q is a tautology, then we say the P and Q, both the compound propositions are equivalents. Generally, the logical equivalence is represented by this symbol, three lines. Right? Simple examples. If you take P is one statement, P is a statement. If P is a statement, uh, then the truth values for P is 2 only, true or false, right? So now I'm taking the second one. Second statement is always true. So P or T. So P or T. If you observe P or T, if P is true and T is means it is nothing but true only. True. So this one is also true. Similarly, if P is false, the T stands for the true only. One is false and another one is true, but P or T is always T. So if you observe, then these two are true only. Therefore, this is nothing but this compound statement is nothing but the tautology. If the compound statement is nothing but the tautology, then P and T are equivalent. P and T are equivalent. So some of the very important uh, formulas, logical equivalence, famous logical equivalences, right? So very important. So we can use the truth tables. We can use the truth tables to prove this one. So by what is logic? Logically, they are equivalents. Logically, they are equivalents. So first one is identity loss. So please remember all these laws. In future, we are using this identity loss or idempotent laws, double negation, commutative law, and everything we'll use. So identity loss. What do you mean by identity law? So P and T. So P and T. So P and T is always P only. So if you write the truth table for P and T, if P is true and true only. So first one, right? If P is false, if P is false and true is always false only. So P and T is always it is equivalent to P only. So P or F, P or F is always P only. P or F is always P only. So identity law. So identity. So if you observe P and T, P or F, P only. So this is identity loss. Similarly, domination loss. So domination loss is nothing but P and F is equivalent to F only. F stands for false. Capital T stands for true only. So P or T is always it is equals to T only. Idempotent loss. So what is idempotent law? Idempotent law is P and P is equals to P only. If you want, you can write P true, false. So P and P is equals to P only. P or P is equals to P only. This is nothing but the idempotent law. Double negation law. Double negation law means it is nothing but negation of negation P. If P is any statement, then negation of negation P is equivalent to P only. Negation of negation P is equivalent to P only. Right? Commutative law, we know commutative. So commutative law is P or Q is equivalent to Q or P, or second one is P and Q is equivalent to Q and P. So if you write the truth tables for this one, we'll get the same truth tables for the LHS side as well as the RHS side. Therefore, these formulas are all logically they are equivalents. So associative law. So what is associative law? P or Q or R is equals to P or R or P Q or R. Similarly, P and Q, P and Q and R is equivalent to P and Q and R. So whatever the laws we are used in algebra, same. So instead of operators here we are using and, or, implies and, by implies and negation. The same operators we are using here. So distributed law. So what is distributed law? So PR, Q and R is equals PRQ and PRR. Similarly, P and Q or R is equals to P and Q or P and R. De Morgan laws, negation of P and Q is equals negation of P and negation of Q. Negation of P or Q is equals negation of P and negation of Q. So negation law, P and negation of P is false, P or negation of P is true. So these are all very, very, very important laws. In next videos, we are using to prove the normal forms, and everywhere we use associative laws, distributive laws, idempotent laws, as well as identity laws. All these laws are equals. Logically involving conditional statements and means implies and by implies statements. P implies Q is equivalent to negation of P or Q. So we can use, just work out on this one whether the truth tables for the LHS and RHS both are same or not. Please work out on this one. The truth tables for P implies Q is equivalent to negation of P or Q. Similarly, P implies Q is equivalent to negation of Q implies negation of P. P or Q is equals negation of P implies negation of Q. Sorry, implies Q. P and Q is equals to negation of Q and P. So these are some of the logical equivalences. Please try to solve whether the uh, uh, statements, conditional statements are equivalents or not using truth tables. Biconditional statements, very, 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 very important, right? So P by implies Q is equals P by implies Q and Q implies P. So all these biconditional statements we use in further videos also. P by implies Q is equals P and Q or negation of P and negation of Q. P by implies Q is equivalent to negation of P by implies negation of Q. So conditional statements and biconditional statements, to check whether they are logically equivalents or not, use the truth tables. Right? Thank you.